Hello, my kiddos and kiddas. It's Miss Lloyd coming at you with some dot products with some vectors. So when we're doing dot products of two vectors, we have our length of x and our length of y for both of these vectors. We're going to multiply the lengths of x's and the lengths of y's together and then add those products to get one solid solution. So when we're doing the dot product, and so the dot product is basically like multiplying them together. We just have a special way of multiplying when it comes to vectors. If we're trying to find the angle between two vectors, we're going to find the dot product, so basically multiplying the vectors together and dividing that with the product of the magnitude of each vector. And then from there, we can do the inverse cosine of that situation in order to get your theta alone. When it comes to properties of dot products, because we're multiplying, it doesn't matter the order in which you're multiplying, because it's the same. 2 times 5 is the same as 5 times 2. This also works with vectors. If you're multiplying a vector with 0, you're going to get a solution of 0. If we have a vector multiplying in with the sum of two vectors, it's distribution, which we've done before. If you're multiplying a vector with itself, it is the same as the magnitude squared. And there's an example that I'm going to do later on, either here or with my students. I can't really remember which, but it kind of accentuates that. And then if you're multiplying a number outside of a dot product, that C value is only going to go to one of the values. You could also find the dot product and then multiply the C later. That tends to be what I do, just so that you don't accidentally try to distribute, because we only distribute when we're adding or subtracting. And then when it comes to orthogonal vectors, vectors are orthogonal if you do the dot product and they end up equaling 0. So for our first, we're going to find the dot product of each. I'm going to name my first one U and my second one V, just because they don't have names yet. And I want to plug these values into the dot product itself, so that formula. That means I have 5 times 9, and that's adding with negative 4 times negative 2. And from here, I just simplify. So my dot product of U times V, or vector U times vector V, is going to be 53. Next, they've given me the dot products, or sorry, the vectors, and they want us to find the quantity. So for this first one, they want me to find vector U times vector V, or the dot product of vector V, and then at the end, I'm going to multiply that by vector V again. You could also rearrange this if you wanted to into vector U times vector V times itself, which would be the squared of the magnitude of vector V. So that's something you can always check out a little bit later on. I am going to do this later with my students, I realized. Over with C, I'm going to show them that a little bit. But for this situation, we're just going to go with how it said. I'm going to look first at the parentheses, the stuff inside, order of operations, if you will. Simplifying the inside. So because I now just have a number that's multiplying with vector V, I'm going to replace vector V with what it's equivalent to, its component form. And when I multiply a number, this is what we learned in the last lesson, we just distribute this into each value. And I get my solution. And this is the last problem that I'm going to go over in this video. The rest I'm saving for my students. So we want to find the angle in between vector U and vector V. So that means I'm using the following formula. In order to use this formula, I first want to find my magnitude of vector U and vector V, so then it's easier for me to just plug in. Now that I have my magnitude of the vectors, I can start plugging this stuff in. So we're doing the dot product on top for each vector for the vectors. And I'm replacing my magnitudes with what I found earlier, and those are multiplying together. So I'm going to do a bit of simplification before I plug this into my calculator. And this is something you can plug into your calculator from here. If I were to do the inverse cosine, I would get a theta of 45 degrees, or pi over 4. You could also simplify this further. So because this is 45 degrees, this does end up simplifying to square root 2 over 2, which we know the cosine of square root 2 over 2 is when we're doing 45 degrees. So a couple different ways, whether you're given a calculator or not given a calculator, there are a couple of your options. I hope you found this helpful. If you did, please click like and subscribe. If you think this could be helpful for someone else, please feel free to share. Spread the love.